Hi everyone, welcome to this video where we're going to be talking about using MATLAB and using it specifically for matrices. So this is the first one of these videos, so you can see what I've got here is the page where we've got the tasks that you get assigned or that you can work through yourself. In terms of what this little matrices exercise is all about, it's working with how you can input matrices into MATLAB, how you can work with them, how you can pull bits of them out. And as we move down a little bit further, the last little exercise here is actually using a matrix to rotate a vector. So it's just one little application of a matrix. Now what you can see is I've actually had a go at some of these. I won't always do that, but so you might see the answers when we pop them up. But nonetheless, let's just have a look at some of the things that you're meant to be working with when you work through this exercise. So the first part here talks about matrices with equal entries and asks you to complete the implementation of this create matrix 1 function. And the function is going to return an 11 by 10 matrix, all of the elements of which are equal to 16.6 in my case. So essentially what we're doing there is just creating a matrix, and it's got to have some numbers in it. It's got to have a certain size, and the numbers in it are all the same, and it's a specific number. It gives you a bit of a hint once you go inside this one that you need to be looking at using the ones function. So you can either click on that and figure out what that is all about. The ones function is something that's built into MATLAB, and it just lets you create a matrix that's full of ones. So essentially you type ones and then give it the size of your matrix, 3 rows and 4 columns, for example. It spits out an answer which is 1, 1, 1, 1, 1, and so on in a 3 by 4 size. We can assign that to be something, so we could say A is equal to 1s and make it, I don't know, 5 by 2. So this should come out with 5 rows and 2 columns. And there we are. And you can do all sorts of stuff to that. So you could say 1s, 3, 4, but also then multiply it by, say, 7. So if I wanted to multiply each element in there by 7, and it comes out with 7s in it instead of 1s. So in terms of this exercise up here, creating a matrix 11 by 10, all of the elements of which are 16.6 in my case, I'm going to be wanting to make a function which uses this kind of statement in it. The ones to create the matrix of an appropriate size, 11 and 10, sorry, and multiplying it by some number out the front, in my case 16.6, so that that is the number that's inside the matrix and not just 1. Now when you pop into the exercise itself, you can see it gives you the function template like it usually does. The function is M and it's called create matrix 1, no inputs required. When I've submitted that, you can see down there I've just said that M is going to be equal to a very similar command that I've used in the MATLAB window, but of course with the correct size and the number out the front that I want to multiply by. And that one was correct in that case. Okay, so moving on to the second part, we're talking about using the output variables of a function we're going to create called arrayInfo to answer some questions about the dimensions and contents of a matrix. Now remember that the dimension of a matrix is essentially it's the number of rows and the number of columns. We usually say n by m, or whatever the number of rows is by the number of columns. Back in my MATLAB window, remember I called A a matrix of 1s with 5 rows and 2 columns. We can use MATLAB's built-in size function to get that kind of information back. So if I ask it for the size of A, it should tell me it's 5 by 2. And you can see there it is. It gives me the answer. It's 5 rows and 2 columns. The answer thing that pops out is actually a vector, 5 rows, 2 columns. So when we go into that matrix revision task, there it is. It's actually asking us we want the dimensions of A and then some extra information as well. So we're going to be able to use this size command for part A, dimensions of A. But then we're also asked for the value of an element at a specific position and elements in a last column in rows 3 and 5, so some bits and pieces there. To answer those second two parts, we need to be able to extract elements from a matrix. Now that's actually not too difficult. Let's just make so what I might do so that I've got a vector to work with or a matrix to work with, I'm going to set B to be equal to size of A. Okay, so if I wanted to pick out that 5 there, what I'm going to do is call B, and I'm going to tell it that I want something from the first row and the first column, and I should get a 5, and there it is. If I want the 2, I'm going to tell it I want something from B, still in the first row, but this time the second column. So we're indexing in a similar way to what we would when we index a matrix by hand or on paper. It's a similar sort of thing. Of course, if you've got more rows, you can go to more rows in your indexing as well. So that should be able to help us with both B and C over in that task. The only other thing in there that you might not be aware of is when you answer C, the task asks us to do that as a column vector containing 2 elements. Now you can see when B is set up, it's a row vector. Okay, if we want a column vector, we might want to do something like setting it up as a vector. So let's just make up a number. 27 is my first element. I put a semicolon to say I'm moving on to the next column, and say I want 3 as the next element. So when I print that out, it should be a column vector. There we go, 27 first and then 3, looking like a column vector to me. So we'll need to make sure that we use that when we're in part C there, and calling for the elements in the last column of A and in rows 3 and row 5. Okay, back to the main page for week 6. If we go down to part 3, we're looking at sub-arrays or sub-matrices if you like. Part 2, we were looking at pulling out individual elements of a matrix, but sometimes we might want an entire row or column or a sub-matrix within a bigger matrix. So this task asks us to look at extracting a sub-array from position 1, 1, the first row, first column element, to the 11th row, 18th column of the matrix A. So it's a sub-matrix within the matrix. And what we can do with that is use colon notation. So let's just have a look at an example. I'm just going to make up a random matrix. So I'm going to tell MATLAB to give me one of those. A random matrix, let's make it 5 rows and 3 columns. So there we go, just some random numbers between 0 and 1. Now let's just say I wanted to pluck out just the first row of that. I can tell MATLAB that I want from the D matrix, the first row and all columns. So there we go, you can see that those numbers are exactly the first row. So I've told it I want the first row, and just putting a colon there says put all of the columns in for me. If I just wanted the first 2 columns, I could do something like a 1 to 2. There we go, so 1 to 2 telling it the extent of the columns I want. I could have done row 1 and 2 to 3 if I like, that kind of thing. And you can do the same with rows as well. If I wanted the first 2 or first 3 rows, let's say, and the first column, there we go. And we can combine, we can do it for rows and for columns. So I might want a sub-matrix from, there's our D matrix right up the top. Let's just say I want this chunk here, the first 3 rows, but only the first 2 columns. So D, first 3 rows and first 2 columns. And there we are. So you can check those numbers there if you like, but they should be okay. So that's the kind of command or the kind of syntax you'll need to use to answer this problem here for subarrays. All right, back to part 4, creating a matrix. We're going to complete the implementation of create matrix 2, and it's going to return a 2 by 2 matrix with the elements 18 and 6 in the first row and 0 and 16 in the second row. This one is just simply referring to actually creating a matrix if you know what the numbers are. So let's just say I wanted a matrix which had the numbers 1, 2 in the first row and 3, 4 in the second. I could say E, it's going to have 1 and 2 in the first row. Remember semicolon to go to the next row. 3 and 4 to go into there. So there we go. You can just make it with whatever numbers you want, and that's exactly what's going on in part 4 over there. All right, now the last part of the week 6 activity, number 5 down here, looks at rotating a vector. So we're actually using a matrix, kind of putting together some of the bits and pieces from parts 1 to 4 above in order to rotate a vector around. I might actually go into this one because there's a few parts to it. So you can see we need to create a matrix, and you can see inside there it's got some cosine and sines in it. So we'll talk about that in a moment. There's an important note about using causes and sines here. What you're then asked to do is use it to rotate a vector. Now what you do there is pre-multiply the vector by the matrix, and you have to do that twice. If you read the question up here, it tells you to do it twice. And then finally asks you to check that your result is perpendicular to A, the original vector that you've popped in, to a tolerance of 1e to the minus 10. Now that's all about rounding error and computational accuracy. In MATLAB, you're not going to find the dot product and say that it's equal to 0 in order to get perpendicularity assured. We're looking for pretty close to 0, so something like a tolerance of 1e to the minus 10 can do that for us. Now we're going to do that, as you can see down here, it suggests doing that with an if statement. Now the first thing you might want to notice here is that when you use cos and sine in MATLAB, what's a cos and sine that we might know the answer of? Cosine of 90 degrees should be 0. Cosine of 90 here says that the answer is minus 0.4481. That suggests to me that I can't use degrees in MATLAB. So, well, I can if I convert, but I might want to do pi over 2 instead of 90. And we get an extremely small number pretty close to 0. Okay, so I'm thinking that we should make sure we're using radian angles for theta in here. So instead of 45 degrees, in our task, we'll be using pi over 4 for that. Okay. The next thing you need to know is about multiplying matrices and vectors. The usual rules apply in terms of the sizes of those things needing to be compatible, but MATLAB, of course, won't multiply something if it can't do it according to the rules of matrix multiplication. But you do need to make sure that you know what's going on with that. But in terms of actually doing it, multiplying matrices and vectors, you just use the standard asterisk notation to do that. So we can multiply E and E, and we get an answer, a 2 by 2 matrix. And you'll be able to do that with vectors as well. Now this task is also asking us to check for perpendicularity, and it's doing that with this idea of tolerance. So what we'll be wanting to do is find the scalar product or the dot product of C and A and check whether it's less than 1e to the minus 10. So a check is often thought of in MATLAB as an if statement. So we might say if the dot product of C and A is less than that, then they're perpendicular. Otherwise, or else is the word we usually say, else if C and A have a dot product which is not less than that, it's equal to or it's greater than, well then we'll say they're not perpendicular to each other. So we need to use that kind of if statement. I might actually show you this one just to run you through how I've done it. So here's my code that I've submitted down the bottom here. You can see it's all taken from the template up here, but the inputs, I've changed the R matrix. I've brought in the whole idea of the rotation matrix with the coses and sines and the pi on 4. Then I've found the B vector, which is the rotation of A by 45 degrees. And then the C vector, which is the rotation of the B vector by 45 degrees. And then I'm asking MATLAB to do this checking of whether C and A are perpendicular. So I'm using an if statement to calculate a thing called D. Now D is just going to be a binary indicator, whether or not the two things are perpendicular to each other. So what I've done here is I've said if the absolute value, that's the abs function, of the dot product of A and C. So MATLAB has something built into it that finds dot products. You could hard code it if you like, but why not use the dot product if it's there? So find the dot product of A and C, get its absolute value, and test whether it's less than this tolerance, 1e to the minus 10. If it is, then we set D equal to 1. Else if it's not, we set D equal to 0, and that's the end of the if statement, and then the end of the function itself. Okay, so this is going to spit out a number. Well, it'll give R, B, and C, but importantly, D equal to 1 or D equal to 0, and that allows the program here to test whether you've got the right stuff in there. Okay, so that's it for this matrices activity that we've got. Just as a quick summary, we've looked at creating matrices with entries that you know, matrices full of ones or exactly the same number, multiplying matrices by constants or scalars, plucking out pieces of matrices, elements, rows, submatrices, columns, that kind of thing, using the colon notation, and then finally looking at some matrix multiplication and vector rotation and bringing in the idea of an if statement. Just to finish up, you've probably noticed that a lot of these things we're implementing as functions. Even though in a lot of cases they're actually fairly simple things like making a matrix with numbers in it, which doesn't require a function. The whole idea here is to get you used to the idea of creating your own functions for later work when you need to build more complicated programs where you're combining lots of different functions, different if statements, whiles and for loops and all these kinds of things. So getting used to the syntax for functions with simpler problems. Of course, you've seen me mucking around over here in the window just plugging things in. You can always do that with MATLAB's command window, just mucking around, trying things out, and that can help you in your process of constructing those functions. So, play around, look at these things, check out the help files as you go through.